In this tutorial, we will be giving an introduction on how to use City-Scale AR. City-Scale AR enables the placement of digital objects on a world scale. Directly within Lens Studio, different city meshes can be accessed to occlude and place digital objects within a city. What's truly remarkable with City-Scale AR is that you can place digital content directly from Lens Studio on a specific street or in front of a specific house and be able to visualize that directly from your mobile phone. In this first tutorial, we will be discussing how to place different digital objects within a street and how to make those objects appear when your phone screen is tapped. The first thing we want to do is open the City-Scale AR template directly within Lens Studio. Once that is done, you should see something a little bit like this, with different City-Scale AR objects and scripts attached, and the city mesh should be visible in the sky, which means you can zoom out and see the mesh as a whole. In the City-Scale AR templates, the City-Scale AR script allows you to simulate when a location is near, far, or has been found. When the location is near or far, you will get different UI elements that tell you to get closer to the city mesh. When the location is found, your city mesh will be displayed and different components placed on the city mesh will also be visible. The City Mesh in Scene panel is only there for you to visualize the City Mesh in Lens Studio, and the City Mesh in Lens is really useful as it allows you to control different features such as physics colliders on the City Mesh and also choose the material for your City Mesh in your lens. The material parameters allows you to control different settings regarding the touches on the City Mesh. The Raycast City Mesh sends out a callback whenever the City Mesh has been tapped, and the ground Y estimation calculates your height in regards to the City Mesh. Inside the City-Scale AR content, different examples have been included within this template. You can explore how these examples work to get a better understanding of how City-Scale AR operates. By default, we seem to be located in central London, which is something we can change by going into Window and clicking the map. Here, it will open another window, and as you can see, a blue indicator tells us exactly where we are. Here, it appears we are in Soho in central London, where some content has already been placed. If we click on another location, it re-downloads the city mesh. If the AR experience you want to build is located in a different city, such as Los Angeles and Santa Monica, you can select it right here on this scroll down menu in the map window. As we are currently located in the preview window below the city mesh, we can actually unlock the y-axis and change the camera speed, which allows us to quickly view the entire city mesh directly within the preview window. Using the WASD and spacebar, we can navigate around this environment at really quick speeds. Before starting our project, we want to delete the current examples in the city template. For the example we'll be making in this tutorial, we will be going near Paddington in this street right here. Once the right street has been selected, you can see in the main scene window that the city mesh will be loading. Sometimes the city mesh can load quicker in the preview window, which is perfectly normal. For a better preview of the street, it is possible to click around and navigate the map window to find the perfect section for working on our project. Once the perfect street section has been selected, it is possible to double-click the map to drop a pin. This pin acts as an anchor, which allows you to place content directly in a specific location on the map. The pin can be added to the City-Scale AR content scene object. The next step is to import the 3D model for our project, which we can do right here and click import. Once the 3D model has been imported, we can actually rename it directly within our resources and quickly drag and drop it directly below the pin we made earlier. As you can see, the tree has been placed within the scene, but is very small compared to the city scale mesh. The most practical way here to position it correctly is actually to directly within the scene panel, position the tree in relation to the city mesh. Using the little gizmos here allows you to drag it across the X and Z plane which will keep the tree here at floor level for the city mesh. This part of the video has been slightly sped up as I am adjusting here the position of the tree, and then you can actually go and see it directly within the preview window. What I'm doing now is making the scene object tree a little bit easier by removing the prefab and a few other parent objects. What we want to do next is select the tree and add a script component, and then add a tween transform right here. The reason why I'm doing this is to actually make my tree scale out of the ground and make it seem like it is appearing from nowhere in the street. If you do not have the tween scripts, you can search for it directly in the resources panel. To test the tween, I can click play automatically and you can see the tree appear out of the ground. The tree here appears before the mesh is loaded. To control all the trees that we will be adding to our scene, we actually want to create a script which will be able to handle all of the spawning of those different trees. Once double-clicked, the script can be directly edited within the script editor of Lens Studio. The first thing we are doing here is creating two types of events, an onStart event and an onTap event, which are bound to two different functions. A function called start and a function called tapped. We are then making an empty array where all the trees will be located and counting the amount of scene objects that are located below the script scene object. In our start function, we are using a for loop to apply a modification to all of the trees that we will be placing within the scene. And what we want to do here is that for every existing tree, we want to add it to the array that we created before. This is done by using getSceneObject.getChild and cycling it for every single instance. What we also want to do is set the scale of our trees to 0, 0, 0 and apply it to every single instance. And what we can also do is using the tween manager set the end value of our trees, which is the value to which the trees will scale. We target every tree in every instance, the name of the script, and set the final vector. To apply our script, we then want to select the pin and drag and drop it directly on the inspector. We can immediately see that we get an error, and this is occurring because the tapped function does not exist yet, and we are trying to create an event around the tapped function. So we want to create it, and as you can see, if I press Command S or Control S, the error is fixed. We are then using a for loop again to reselect all of the different trees within our array, and we are basically using the same count and the same number of iterations for the for loop, and then using the global tween manager function, we are calling for the start of the tweens on all of those trees. As you can see on the preview window, when I click my screen, the tree appears. Oh, and for this particular 3D model, I'm making a little change to the materials, selecting all of them and removing two-sided. We can now start with the process of duplicating all the trees. For this example, I'm doing this manually because this allows us to have a more visual preview in the scene window. And then to make the effect a little more dramatic, I'm going to add a slightly bigger delay on every single tree that gets added over time. This process is fairly straightforward and I can just manually copy and paste. I'm actually using Command D to duplicate those trees right now, which is a quicker and easier way of doing so. Finally, to create the effect I want here, I'm going to select all the trees and duplicate them, which will take a little while. And once those trees have been duplicated, I can just directly drag them and bring them to the other side of the street right here. Once I'm happy with the position of the trees, I can go back to the preview window and actually preview this effect in real time. By just tapping my screen here, all the trees come out of the ground. If we want to make this effect more realistic, I recommend adding an occluder to the city mesh, which can be simply done by adding the occluder material and dragging it into the city mesh script. And while we're at it, we can disable physics as well. And that's it. The effect has been completed and works perfectly in the streets of London. If you have any questions, please drop them below and we'll try to answer them as best as we can. A final tip I recommend is that if you can, bring your laptop where you plan on recording your videos, as it really facilitates testing on the field.